Hi guys, welcome to 16-Bit Bench. Matt here. Today we're going to be looking at this Master System 2. This is a French Master System 2, so it already has RGB on board, and it uses this adapter box that has a little circuit board in it to sort of smooth out the RGB. The problem with the Master System, and it's not just the French versions, it's all the versions, is the DIN socket on the back is not really designed to be plugged in and out of continually, and this Master System's had a rough life, and what that means is the DIN connector has kind of got dry joints on it. So if we turn it on, my TV will automatically pick up the 5-volt line coming on the SCART cable and switch to the AV input. It's RGB, so I'm going to switch it to RGB on there, and as you can see there's no picture, and what we will get in a couple of seconds is the sound of Batman. Yeah, but there's no picture coming out, so it's probably the sync line is broken on the connector, or all the video lines are broken. So what we're going to do is open up the console and we're going to take a look inside. So here we are on the bench. We're going to crack this open and take a look inside. So here we go. This is the board with the shielding on. You can see the shielding's a little bit rusty. I don't think this Master System has been stored in the optimum method. Yeah. So to get, oh look, it's nice and shiny on the bottom. To get the shielding off, you just need to bend back this single tab. So let's get some pliers. Let's bend that tab. And then on this side there's two screws, both going through a heat sink for this, I think it's a voltage regulator over here. So we'll just unscrew those two. Well, unscrew the top one first. I don't think you actually need to take the bottom one off. Here we are, here's the board. So I can see there's some corrosion around here that we're going to have to clean up. Yeah, it's dirty, not going to lie to you. Let's turn it over. So this is the problem area here. If you can see, here's the DIN connector, and it is secured to the board with a metal strip, but it's still not really enough for the amount of force that's required to insert and remove the DIN cable. It would be fine if this console was set up in a TV unit and was left there for its entire life, not a problem. But when it's moved around, and these ones were used for retro shows in France, so it's been moved around quite a lot, and that means that this little guy's been plugged and unplugged tons. So yeah, that's what's probably caused the problem. Yeah, so why don't I get my phone and take a close up. So you can see the pins for the DIN connector. If you look at, let's find something to point with. There we are. If you look at this one, you can see it has a very faint ring around the pin there, and the same for this one. There's a ring around the pin, and what that is usually an indicator of is a broken solder joint. So what's happened is the action of the connector being moved has snapped those solder joints. So a quick and dirty fix would be to get your soldering line and just reflow those pins, but we want to have a longer term fix here. So what I'm going to do is I'm actually going to run wires to replace these traces on these pins. So I'm going to run physical wires along the bottom of the board, and then I'm probably going to hot glue the connector down to the board and over the wires. So on the shielding, we take a look, this shield fits about here, and that gives us a little bit of wiggle room here on the plate. You see where the cutaway is for the connector. That means that we can put material in this space, so that will allow us to put some hot glue in there and some wires to make sure that cable stays nice. The connector, sorry, stays nice and stable. What I have done in the past on these is I've replaced the DIN connector entirely with a new connector. The layout of the bottom pins is about the same, but the grounding pins were different. So what I've done there is drilled holes either side of the connector and run a cable tie through, and what that does is replace the functionality of this strap here, and holds the connector to the board, and that's on top of running wires and hot glue. So yeah, so the next step is to clean the board up, and then we'll run the wires in and put the hot glue on. So let's get to that. So here we are, a little bit of a closer view on the board. All I'm going to do is just liberally cover it in isopropanol, scrub it with the toothbrush, and try and get some of this white stuff off, which is, you know, corrosion and water buildup. I think it's not been wet, but it has been damp, so that's never good. Yeah, so I'll do that. Let's just take a look at the board here so we can just see the layout of what's going on. So here you've got the Zilog Z80 processor, and there's a ROM chip there. I think this Sega chip seems to be doing the video encoding, and then we've got, I think, some RAM over here and another custom Sega chip. What you would see down here is a composite video encoder chip, and you can see that's missing, and all of the discrete components around it are missing. So what's happening is the RGB encoded video is coming straight off of this chip and is being jumpered in various places to get it out to the DIN connector, and then what's happening is this little box of tricks has some circuitry in it, which I think what we'll do is once we've got the board up, I'll show you the inside of this, and we'll see what's going on in here. But there's some circuitry in here that's taking the incoming RGB signals from the chip and is then encoding them in some way. I'm not 100% clear what this box does, but the console only works if you have one of these boxes, and I think that's because the pin out is different. So reading the forums, it suggests that these are to make the picture better, and that's probably the case. What I need to figure out is how the Master System French RGB pin out of this connector differs from the standard. So what I'll do is I'll just put up a picture now of the RGB connector pin out for the Master System, and you can see there's the red, green and blue pins are highlighted on it. I don't think that the output of this DIN connector matches that. I think it's completely different, because when I use a standard 8-pin DIN connector into this connector, I get no video, even on a working machine. I know this one's broken. So yeah, we'll have a look into this box. We'll have a look into this box at the end of the video. In the meantime, we'll continue on with the repair here. Right, the board's all nice and clean now. So what we're going to do is run wires to sort of supplant the traces that are on the board. And what that'll mean is there's no longer a requirement for there to be electrical connectivity from the pins to the traces. Like there'll be a wire in there. When I cleaned it up, I can see more of the problem. So let's just get the phone and I'll just show you a close-up. So I think now it's much clearer that there's clearly a broken solder joint here, there's a broken trace here, there's a broken trace here, there's a suspect trace there, there's a dry solder joint here, there's one here. In fact, the only pin that's any good is probably this one. and I think that's ground anyway. So yeah, we're going to replace all of these with wires, and I'm going to reflow the ground sort of pins over here as well, and then we're going to hot glue the whole mess together so it's less likely to move around in the future. What I'm going to use on the pins is a single strand small gauge wire. I think this is 0.8. I can't remember. I don't even remember where I got this from, to be honest. I've had it so long, and all I've got left is the orange because I didn't use the orange. Yeah, so I'm going to run orange wires to replace these traces, and yeah, that should fix the problem. You can see that funky electric orange wires looking pretty cool. So I've just ran wires to replace these traces here, or sort of supplement the traces really. And as I mentioned before, there's only one pin that goes nowhere, and that's pin 3. Yeah, and there's quite a few hops on some of these wires. Like this one goes along this trace into this via under the board, back out of that via there, which then runs along here and up to here. So that's where I've put the wire, and the same for this long one as well. You can see it's coming up here. There's a via there. There's a via there. It jumps over there. It comes out there. So yes, it's pretty interesting. The reason for that is that this board is meant to have a load of discrete components in this region. There's meant to be a composite encoder chip. There's meant to be loads of crystals and capacitors and resistors in order to create a composite video signal. Right, so I'm just going to use the iPhone to do this bit. You can see there's the board, we're plugged in, we've got Batman Returns in there. There's the TV on RGB mode, so I'll just turn the console on, put that to RGB again, there we go, Sega. So you've got to check the colours there, you can see that's a proper blue. So we're looking for red, green and blue elements in the picture, which will tell us all of the lines are connected. There's the start screen and the Batmobile. So on this screen we can see yellow, we can see green here in the house, and this orange colour gives us a pretty good indication there's some red there. And let's just start the level. And you can see, it looks to me like there's red. But what we can do is try another game just to make sure. Okay, so this is the built-in Alex Kidd, and there we are, nice big red, green, blue title screen with the built-in Alex Kidd that's on this console. So cool, yeah, we fixed that problem. Got my super snazzy little baby precision glue gun and some excess glue. And what we're going to do is we're just going to not, coat it with glue. I'm just going to put some reinforcing glue in this area. And that's it's to keep the wires down on the board. It's to stop the connectors from moving around, and it's just to to make a sturdy job of the whole thing, really. All I'm going to do on the top is run a bead around the connector, the DIN connector, just to make sure it's a bit more positioned on the board, it doesn't move around. There we go, so that's all the gluing you need to do, and again it's just a precautionary measure. It's not really required. It worked. We plugged it in and we saw it working. The glue adds no functionality, it just adds stability. So the next thing I'm going to do is give the case a bit of a dust out because it's filthy, and then we'll put the console back together. And when I've done that, we'll take a look at the RGB adapter and see the board inside that, and try and figure out what's going on there. the master system's now back together, so what I thought we'd do is take a look inside this adapter box. It says on the top, adapter RVB, which is French for RGB adapter. On the back, model 3085 Sega, made in China. So yeah, let's pop it open. Usually 2 screws in there, but I already took them out. So what we have is a little circuit board inside. A lot of discrete components, standard values. Looks like 10 microfarad capacitors, 220 microfarad capacitors, the bigger ones, some diodes, some resistors. Probably I'm going to guess 75 ohm resistors because it's video. And some other things, 10Ks. Yeah, it's nothing massively surprising. We've got a Texas Instrument chip here, a TL497ACN. So yeah, let's just look that up. Yep, so the TL497ACN is a voltage regulator. This is what it looks like. Here's a picture of it. The full data sheet is linked in the description below if you're interested. I'm not 100% clear what this board does. If you have an idea, please comment below. That would be great. But yeah, to me, the main problem that I'm seeing with this board is that if you look at the incoming signal from the DIN connector, the green wire is labelled red on the board, and the red wire is blue, and the orange wire is green. And then coming out of the board on the other side, the green wire is green, as you'd expect, the red wire is red, and the blue wire is blue. So that seems to indicate to me that the signals coming from the master system are swapped around for some reason, and you need this converter board in line in order for your TV to be able to decode it. And without this, you can't use the French master system or on a TV. So one of the things I'm going to be looking at is, do I have enough of these cables to match up with the big pile of master systems that I have? And if I don't, then I'm going to have to look at changing the pin out of the DIN connector on the master system so it matches the standard wiring in the standard 8-pin DIN SCART cable that you can get anywhere off eBay or anything. And that's the cable that works in the Mega Drive 1. The Mega Drive 2 has a smaller DIN connector, but again, neither of those use anything like this RVB box that's in the middle. And here we are. Master system is back in perfect working order. I'm going to play some Operation Wolf. Why not? Reason 1 to have a light gun and a CRT. I mean, come on. Of course, at this range, it's basically cheating. And you need the second pad plugged in so you can fire grenades. I don't have it. And I don't know why the nurses tend to hide behind soldiers. Right, anyway. So that's how to fix a master system. That's not just the French RGB versions. That's all of them that have the DIN connector. They all suffer from the same problem. That's the master systems too, and the originals as well. They all have this problem. So if you come across one, in a thrift store or second hand online, it says it doesn't work. Pretty much that's one of the things will need to do to get it online. So thanks for watching my video. Please like it if you liked it. Please subscribe if you'd like to see more. Follow us on Twitter and Facebook, 16-Bit Bench. And I'll be posting, when this video goes live, I'll also be posting out some pictures of that RVB connector as well, so we can have a look at that. So thanks for watching, and I'll see you next time.